right, so today we're going to talk about summarizing quantitative data. So we're doing more with quantitative data, and this is just going to be day one. So we're going to break this out a little bit. So what we're going to talk about today is this whole concept of center. So if you remember with SOX, today the focus is going to be on the C part of SOX. Now, when we talk about center, we have three things. We have the mean, we have the median, and we have the mode. And this goes way back to elementary school. And so the mean, think of this one as the average. The median, think of this one as what's in the middle, right? And the mode is the one that where we see the data value we see the most. Now in AP Stats, we are not going to use mode. All right, so everything is going to be mean and median. All right, so we're going to start with talking about the median. So the median is the midpoint of the distribution. And this is only for quantitative data. And if you remember, it's not categorical because we could put the categories in any order. So it's just quantitative data. And it's the number that is about halfway. So half of the observations are smaller and half of the observations are larger. So it's the one that's right in the middle. So to find the median, we have to arrange the data from the smallest value to the largest. And that's important. Okay, so if the value of n, and n is our number of data points, if that value is odd, then the median is the middle number of the entire set. Okay, if the value of n is even, then we're going to use the average of the two middle terms. Okay, so this actually makes a lot of sense if you look at these things on a number line, and if we have four numbers on a number line and we want to know the middle term, well, the middle term is going to happen right here, right? So it's going to happen between 3 and 4. And so we're going to take the average of these two, and that's going to give us our median. Okay, so we are always going to do this by the calculator. We're never going to do these by hand because we don't have to. So you can type all of these values into Desmos, or you can type them right into your calculator. So again, from your calculator, you're going to go to Stat, and you're going to go to Edit, and you're going to do your list. Now we've got all these numbers in here from something else, so I'm going to arrow up to the top where it's L1, and I'm going to hit Clear. And if I hit Clear, then that erases everything that's in my data set. Okay, so now I'm just going to add my numbers. Oops. Okay, so 20 data points. I put all of this in. And then to get this, what we're going to do is we're going to go back to Stat, and we're going to go over to Calc, and we're going to do one var stats. So this means one variable statistic. So I hit one var stats. It asks me where my data is. It's in L1. We don't care about any of this other stuff. We hit Calculate, and here's everything. So if we arrow down, so you use your arrow pad right here, and you arrow down, you see MED. And so right here, it tells us, so we're using one vars, and we arrow down, and our median of this data set is 58.5. And it's literally that easy. You'll never do it by hand. You don't have to put your numbers in order. You don't have to do anything. We know where our median is. It's right here. So if we want to interpret the median of this, the median feeding rate that's calculated, I didn't even read the question here, but basically if we want to calculate it, what it means is that this value of 58.5, that is the number that's in the middle. So half of the numbers are going to be less than that, and half the numbers are going to be greater than that. So when we get down to the mean is going to be the average. So the mean of a distribution of quantitative, again, we can only do this because we're dealing with numbers, is the average of all of the individual data sets. So you would add them all up, and then you would divide by the total. And our total is always going to be that lowercase n value. Okay, so if I go back to my data is already in there, and I do stats, calc, 1 bars, you notice when we had median, it tells us MED for median, but it doesn't tell us mean. And so let me talk about some specific ways that we identify. So flip on over here. Here we go. So the symbol to denote a sample mean. So this is just a sample. If we go back and we look at this data, what this is this is feeding rates of 20 different crabs. So these are their feeding rates. So this is a sample of 20 different crabs. Now, we have a total population, which is going to be all of the crabs in Indonesia, but we have a sample of 20 different. So because we have a sample mean, we use this value that's in our calculator. So right here, this X bar value is 72. So how do we pronounce this symbol? It is literally X bar. So we say X bar. And what does the formula mean? So my formula is X bar is going to be the sum of the data over the total number of values. So what this would look like would be X1 plus X2 plus X3 all over n. Now, what you're going to see is that that looks like this. Now this right here is on your formula sheet. When do you need to use this? You really don't, because your calculator has everything for you. So let's talk about what this means. So this is called a sigma, and this sigma just means sum of. That's what that means. So what we're saying is the sum of X sub I. So X of all of the different data sets. So if I only had 3 numbers, it would be 1, 2, 3. So sample 1, sample 2, sample 3 over the total. So all this sigma means is sum of. That's all it means. Okay, so here is, oh, those are both about crabs. Okay, sorry, I guess I didn't realize that. All right, so here what we have is we want to calculate the mean feeding rate of these 20 crabs. So I'm going to go ahead and pause the video, and I want you to plug that in your calculator and do that really quick. It's not going to be what we just ended up with. Okay, so since you had that in, really all we need to do is pull that off of the calculator. So we get 55.5, and this is going to be scoops per 30 seconds. And so because we have a value, we're going to have a unit on that. So we go to the second part of this question. It says, research has excluded 1 crab with an unusually high feeding rate of 127. So if we were to add this back in, calculate the new mean. So what I'm going to do is I'm going to go back to stat, edit, I'm going to go all the way down here, and I'm going to add one more value. And so that value now is 127. And you see here, it tells you L1 21. This 21 means now we have 21 data points, and that's what this says. Now calculate the mean feeding rate for all 21 crabs. So now I have this value of 127. I go in here, stat calc 1 bars, and now it tells me that my mean feeding rate, so my X bar now is 58.9 scoops per 30 seconds. So what happened? So what happened is as we added really an outlier, we see that our mean value changed. Our value went up. So if I had all of these data points and now I add this value out here at 127, and before that my values were clear down here in the 70s, this took my overall average and it moved the whole thing up. So what we do when we calculate a population mean is we have a different symbol. Remember, X bar is my sample mean. I have a sample of data points. But if I took multiple samples and I took this sample of 20 and then another sample of 20 and another sample of 20 and another sample of 20, those are called simulations. And as I add all those simulations up, what ends up happening is I get closer and closer and closer to the population mean because I have more samples in my sample set. So my population mean is this kind of almost like a U. And this is pronounced mu. It's this Greek symbol that's a U. So our symbol of X bar is a statistic. And the symbol of mu is a parameter. And if you remember, we did this on the first day with definitions. The statistic comes from a sample, and the parameter comes from the population. Now, you'll notice that when you go in here and you look at your 1-bar stats, there is nothing for mu on here. Like, we don't have that as an option, and it's not an option because we don't have enough data. We only have 20 data points. All we're going to get is our sample statistic, okay? All right, so important concept, the properties of the mean. So the mean is not resistant to extreme outliers. So we see that. So our mean changed because we added this value of 127, right? So a statistical measure is resistant if it is not affected by extreme data values. So let's go back and look at this again. I wish it would save. So stat, calc, 1 bars. So this list, remember, this list has that outlier of 127. So I had this outlier of 127 in the list. And now if I scroll down here and I look at my median is 59. We said with that original data that the median was 58.5. So the only reason why the median changed is because we went from an even number of data values to an odd number of data values. So because of that, we had to take that number that was going to be in there and average those two numbers that are there to get that value. So is the median a resistant measure? Yes. And we just talked about that. So we've got these data values. We've got this data value clear out here at 127. And now we take these values in here, and our lowest and our greatest are going to be canceled out. So what does that mean? That means that the mean is sensitive to extreme values because the mean is the balance point of the distribution. And so this is really important. This is super, super important. The mean is sensitive to extreme values. And this extreme values here, we're going to call those outliers. And what we're talking about here is if it was a high outlier, but if we had one down here and we said that the value was 3, that would be a low outlier. So that would still affect our change in mean, okay? So if we look at this, we've got a couple things going on. The relationship between mean and the median depends on the shape of the distribution and whether there are any outliers. And so when we get back into SOX, when you get to the center, you have to look at these two things. Because sometimes you're going to report your center as a median, and sometimes you're going to report your center as a mean. You don't get to pick anymore. So a minute ago when we were looking at those distributions, we were just kind of trying to find the average of the two, and that doesn't work anymore. Now we have to look at the shape and we have to look at the outliers. So here's a cheat way to look at this. This is a skewed left distribution. So this is a skew left distribution. So because we've skewed to the left, we've got this data that comes out here. And so what we see is that this triangle point that's right here, let me make a little table. This triangle that we have here is going to be our mean. And this line that we have here is going to be our median. So if we have something that's skewed left, we see that our mean is less than our median. That makes sense, right? So if we're taking and we're putting in these extreme values, it's going to drop our mean, and our median is going to be right here. If we see something that looks like this, So I have no skewed data. So I'm going to say that this is roughly symmetric. So I've got some values here, but the majority of my data is distributed pretty well. And what we see here, hold on, let me go back because I want to change this. So my mean is less than my median. When it's skewed left, the mean falls down. Here, I see that my mean is almost the same as my median. And we'd use this when they're roughly symmetric. Here, what I have is something that's skewed right. And if we look at where our mean is and our median, this tells me that the mean is greater than the median. And I can also look at this as x bar is greater than the median. So for mean, we use x bar, but for median, we still use MED for median. That's not going to change. All right, so to summarize this up, because this is what's important, is if a distribution of quantitative data is roughly symmetric and has no outliers, the mean and the median will be equal and almost equal. So what this could look like is 58 equals 58.5. Now, if you are super mathy, you're going to be like, okay, but 58 does not equal 58.5. In stats, we use these words, roughly symmetric, approximately equal. So when we say that they're equal, that means they're super close. So keep that in mind. If the distribution is skewed, then the mean will be pulled in the direction of the skewness, but the median won't. So this is skewed left, so the mean is pulled to the left. This is skewed right, so the mean is pulled to the right. So bottom line, if we have skewed data, we always use the median as our center. If we have non-skewed, then we're always going to use the mean as our center. And this is going to be always, always. Super important. All right, that's it for today.